joining us. CCTV.net is happy to host Stephen Payne here from Dahua this morning, who's going to give us a brief demonstration about their new solutions. Take it away, Stephen.
Excellent. Thank you, Jack. Good morning, everybody. We are going to discuss two of Dahua's thermal temperature monitoring solutions today. The larger solution is designed to read the temperatures of multiple people simultaneously as they proceed into a facility or walk through the detection area. And the second solution is a smaller solution designed to read individuals individually, one person at a time. More appropriate for smaller facilities like offices, small stores, things like that. So those are the two solutions that we are going to discuss today. Now, just a quick disclaimer up front. These devices are not FDA cleared at the moment. The FDA issued an exemption earlier this year stating that due to the coronavirus situation, these thermal temperature monitoring solutions, temporarily anyway, at least until the COVID issue is resolved, do not require 510K certification, and they are allowed for use to determine people's skin temperature under the circumstances. Now, that being said, we cannot, or these systems cannot tell you if someone has a virus, the flu, or even whether or not they actually have a fever. All we are doing is reading a person's skin temperature and determining whether or not that temperature exceeds a set threshold. Now, as I mentioned, this first solution is designed to screen multiple people simultaneously. We can actually read up to 30 people at the same time as they walk through the detection area. Now, it's not likely that you are going to have 30 people walk through simultaneously, but because of social distancing, but that is the capability of the system. This system reads with an accuracy rate of about 0.5 degree plus or minus Fahrenheit. And I will explain in just a few minutes how we achieve that level of accuracy. Now, one of the current methods for doing temperature screening as businesses try to reopen or stay open, given the current circumstances, is with the use of a handheld thermometer. There are a couple of efficiency problems with this technology. While they are very accurate and they work well, it requires that the individual being screened stop for 3 to 5 seconds or even longer as they have their temperature read before they can proceed on through. And it also requires that the individual doing the screening needs to stand within arm's length of the person they are screening. So thereby violating, again, social distancing guidelines. So this first system provides a way to, again, screen multiple people simultaneously. They do not have to stop for any length of time, and it doesn't require an operator to be within any proximity to the people being screened. The operator can be across the room. They could even be in another room. So what we've basically done is we have taken the concept of a thermal camera and we have designed this camera specifically to operate in the range of normal human body temperatures. On top of that thermal capability, we have added our AI-based facial detection algorithms. So what that means is that as a person enters the detection area, the first thing the system is doing is locking onto their face. It's locating their face and like I said, locking onto them. Now, for temperature detection, the most accurate point on a person's face, the point on a person's face that most closely corresponds to their internal core temperature is the inside corner of the eye. And that is the first place that we look for a temperature. And now if the eyes are blocked by glasses, then secondarily, we're going to look for outside of that, the hottest part of the face. So we're going to check the forehead, the nose, the cheeks, wherever we can see if the eyes are occluded. We're going to get the hottest part outside of that. But the inside corner of the eye is that one spot on the face that most closely matches a person's inside body temperature. So what using that facial detection means is that if a person is wearing a mask or glasses or a hat or some combinations, those that headgear is not going to obscure us from grabbing a temperature. Now, if a person has a mask on and glasses and a hat pulled down over their forehead, and we can't get a clear shot of some part of the face, then you'll get an error, and you might have to ask that person to go back through again and remove the hat or the glasses, some part of the headgear. But normally, just a mask or a hat and sunglasses, normally the use of those accessories is not going to stop us from grabbing a temperature. Now, another thing, the facial detection, another benefit that gives us is the ability to ignore other sources of heat in the image. Unlike a normal thermal camera, which will grab any hot spot that it sees, we are again only looking in the area of the face for temperature. So if a person comes in, like you see in the two pictures here, with a hot cup of coffee, a hot beverage, the system is going to ignore that because, again, it's not directly associated with the area of a face. So we can eliminate a lot of false positives that way. Now, questions do come up periodically about privacy concerns. And just so everyone is aware, we have a number of different ways of dealing with privacy concerns, with privacy issues. One of them is what you see here, where an area of the video image can actually be highlighted and completely blacked out so that you cannot see the individual behind it. Now, the green or red bounding box that's drawn around the face and the temperature data itself can still be seen. In fact, it just kind of floats through the air there, but you cannot see the individual behind it. So that is just one way we have of dealing with privacy. Now, that being said, earlier this year, the EEOC also released updated guidelines on the use of these technologies in the workplace, stating that the use of thermal temperature scanning or screening systems do not violate any workplace ordinances or any workplace privacy issues. And the Medical Data Privacy Act, HIPAA, these systems also do not violate aspects of HIPAA because we are not requesting or collecting any identifiable information from the individuals walking through the detection area. So again, we don't violate either of those data privacy concerns. So these are the components of the system. There are three core components: the thermal camera itself, the NVR, the video recorder, and then the device in the upper left-hand corner of the screen there called the black body. And the black body basically provides a reference temperature for the thermal camera to lock onto that it uses to compare against the individuals as it's screening them. And that's how we're able to achieve the 0.5 degree accuracy level. Now, I will go into more detail on each of those three components in just a minute. The other components here are all options. Now, when this product or this solution was first released here in North America, the idea was for it to be a rapid deployment setup, very quick to set up and get running. So options available are a couple of tripods that you can mount the camera and the black body on top of. Now, if you or your facility or the customer's facility wants to permanently install these devices, they are more than welcome to. We have some installation guidelines and restrictions, which I'll also go over in just a minute. So basically, you have the choice: either permanently mount the camera and the black body, or use the tripods for more rapid deployment type of setup. So either way is okay with us. Now, this is the thermal camera that we're offering. It is a dual imager camera. It has both a visible imager and a thermal imager. Both of these streams coming for these imagers, both of the video streams carry the temperature data overlay. Both of them carry the green or red bounding box drawn around the face. for the facial detection. So both of the streams give you all of the information. Now, again, if there are privacy concerns, if people are concerned about walking directly in front of this camera staring at them or what the camera can see, you actually do not have to use the visible camera stream. You can only use the thermal stream. Likewise, if people are concerned about what a thermal camera can show, you can only use the visible stream. I mean, obviously, you have to have one of them running in order for the system to operate, but you can choose which one, if not both. Now, also, this camera has a white LED light on the face of it that can light up or flash if someone triggers the high temperature alert. And it also has a speaker built in, so you can have a custom announcement play if you wanted to. Like, please, you know, high temperature has been detected. Please step aside and wait for further instructions, kind of thing. So both of those functions are completely optional. You don't have to use them if you don't want to, but they are there built in as part of the camera. Now, this is a device I mentioned just a few minutes ago called the black body. The black body, like I mentioned, it provides it emits a stable, calibrated amount of heat energy from the face of it. This heat source is locked onto by the thermal camera. During the setup process, you actually draw a box around the face of this device to show the camera where it is, and it needs to be seen by the camera at all times. And again, the camera will use this heat energy, use this reference temperature to compare against the individuals coming in order to get the half a degree plus or minus accuracy that we advertise. Now, another function of the black body is that it eliminates the need to manually recalibrate the camera if the ambient temperature in the area of the camera changes. Now, the camera also detects the ambient temperature around it and can make adjustments if the ambient temperature changes. But if it were to change on a large scale, like seasonal temperature changes, large air conditioning handling units, or heaters, the black body, again, having that in place eliminates the need to manually recalibrate the camera. The camera will keep itself calibrated by locking onto this reference temperature.
Hey, Stephen, we've got a couple questions from the chat.
Sure.
First off, do we need the NVR if the customer doesn't want to record? And can the triggers and live streaming be set up without recording to an NVR?
I will get to both those questions in just a minute.
Oh, okay. My mistake. Sorry for interrupting you.
No problem. I will answer those questions. Don't worry. Okay. So for your mounting options, we do have some different wall or ceiling mounts. We have the tripods. So we have lots of different options for mounting the devices. So to go back to the questions that just came up, the NVR. Aside from its normal function of recording video, the NVR actually provides us with a few other functions for this system. One of them is that you can plug a regular computer monitor into the back of it, and this can be your operator's main viewing station for the system. You will get the interface like you see in the image below with the 2 video streams, and the NVR also can grab snapshots of each person's face as they're having their temperature screened, and those snapshots will scroll up along the right side of the screen. And if a person reads with a high temperature, they will be flagged and a little banner will be put across them showing they have the high temperature. And then after the fact, those snapshots can be searched against to find instances where people came through with an elevated temperature. So you could go back and say, show me between 1 and 3 o'clock anytime somebody came in with an elevated temperature. That is completely optional. You don't have to be doing that, but it's there if you want to. Also, this recorder provides a hardware-based alarm output from the back of it that can be tied into external systems. So you could say have a external light turn on, or an external sound play somewhere, or if you had an access control system in place, you could use that alarm output to trigger a door to lock if someone read with a high temperature. Now, here I'll go, but now I'll go into the questions that were answered. So there are a couple of ways to get the video streams from the camera without the NVR in place. You could have the camera up by itself, and you can navigate to the web page of the camera and show that on a video. The problem is the alerts. So in order to get alerting, in order to see the alerts pop up on screen, in order to get email and or text alerts, in those cases, you would need the NVR in place. Now, the only exception to that is our free DMSS phone app for iPhone and Android. You can connect that directly to the camera and get the alerts pushed to a phone. But without the NVR in place, that's the only way to get alerts out of the camera. Now, the camera does have its own relay outputs, its own alarm outputs, so you could tie those into a light or an audio, amplifier or something to trigger a sound. You could also do that just from the camera. But if you wanted the more in-depth alerting, like on a monitor, email or text alerts, those things do require the NVR. So hopefully hopefully that answered at least one of those questions. Let me see here. Is this camera? No, so the other question was, is this the actual camera that is required? Meaning this camera right here, the 5421. Yes, this camera has been specifically built for this application. So no, you cannot use just any other thermal camera. Currently, the 5421 is the only one we have for sale in the US market for this solution. Okay, so hopefully Gil's got the first couple of questions there. So, as I mentioned...
Yeah, that's it. Thank you.
Yeah, okay, great. So, as I mentioned a few minutes ago, we do have some installation guidelines or restrictions, we'll say, to make sure you get the best performance from the system. Excuse me. The first one is, and the main one is, that this system is designed to be installed indoors. I did mention that it does have some resilience to or against ambient temperature changes, but again, that is based on an indoor controlled environment. Things like direct sunlight or wind or breezes, those can all affect a thermal camera's ability to read temperatures accurately. Especially when you're getting a specific range of temperatures like we are here. So we definitely recommend that this solution be installed indoors. Another important consideration for a system like this, these types of technologies, is that this should not be considered your only tool in the toolbox. This should be considered a preliminary screening tool only. So it's very important that if a solution like this is going to be used, that some sort of secondary screening solution is put in place as well, possibly with the use of a medical grade handheld thermometer, so you can verify what the camera is telling you, as well as some sort of interview process or questionnaire to determine whether or not an external condition may have caused this person's temperature to be elevated. Things like standing out in the heat for a long time or recent exercise, those things can all artificially raise a person's skin temperature. And unfortunately, from a technology standpoint, there's not a whole lot we can do about that. That is just biology. So there's a couple of ways we kind of recommend mitigating that. One of them is with the use of a back and forth cue like you see here, and I'll show you another picture of it in just a minute, like you would have at a TSA checkpoint or a bank. something to route the individuals back and forth a couple of times when they get inside. All a person needs for their bodies to acclimate to the inside temperature, the inside environment, is literally a couple of minutes, 2 to 3 minutes, for their body to cool down and acclimate to that internal temperature. So, what this system, or how this system should be looked at, is a preliminary screening tool. So it's designed to screen large numbers of individuals as they enter a facility, without making them stop for any length of time. A person coming through does not have to pose for the camera. They don't even have to look at the camera. They just have to walk properly through the detection area. If they don't have an elevated temperature, they can keep on walking and go about their business. But if they do come through with an elevated temperature, then that is the time where that secondary screening process I mentioned should kick in. Again, verify what the camera said with a handheld thermometer, and determine if there are any external conditions that may have caused their temperature to rise. Again, at that point, that might have just given them the couple of minutes they need for their body to cool down, just that secondary process. And you might be able to ask them to just walk through again. And at that point, they may be okay. They can keep on going. So again, secondary screening, more detailed screening process is important with any of these type of thermal technologies.
Hey, I'm sorry, I have a question. Like,
Yes.
are you legal to sell in the US?
Yeah, absolutely.
Okay.
Yeah, we wouldn't be having this presentation right now if we couldn't sell it. Yep. We are absolutely legal and proper to sell in the United States.
Okay. Because I read a few articles where it says that to prohibit a big vision and
Yes.
companies are.
So just to clarify that, since you brought it up, and thank you, just to clarify, we cannot sell into any federal government or federally government funded projects. We do have that restriction, but outside of that, we are completely able to sell anywhere else in the U.S. commercially, municipal or state projects. The only thing we cannot participate in is a federal government project, federal agencies, or a federally funded project.
Okay, thank you.
Okay. So I didn't go through this one. So if you are going to install the devices permanently, or even if you're going to use the tripods, we do have some setup guidelines for the optimum performance of the system. The two devices, the camera and the black body, are designed to be installed anywhere from about 6.5 feet to about 10 feet off the ground. What we really don't want is a camera to be mounted up high, like on the ceiling, looking down on people. We want to get as straight a shot of a person's face as possible. So again, that's why that range between 6.5, 10 feet off the ground is ideal. And then the black body is mounted in the camera's field of view, anywhere from between 10 to 13, 14 feet away, maybe a foot or two lower than the camera itself. Again, the camera has to be able to see the black body at all times. You cannot have the individuals cross in front of the black body. As soon as anything blocks the black body from the camera, you'll get an alarm and the camera will stop reading accurately. So the black body needs to be seen at all times. Now, the idea is that as the individuals are walking through, they are guided either next to the black body or directly underneath it, so that the camera can see both the black body and the individual at the same time at about the same at about the same distance. That is when the camera is reading at its most accurately. So it's very important to have the individuals walk right past the black body, so that the camera can see them both at the same time. Now, again, the individuals do not have to stop. They don't have to pause. They don't have to look at the camera. They just walk on through. Now, one way to do this is to set up a walk path or a walkway and ignore that channel width 1.3 meters. Just ignore that. We've changed that information. But the idea is to design a walkway to guide the individuals through, again, past the black body in front of the camera, and then just allow them to move on through. So you can do like rope stanchions with that, like you'd have at a bank or a TSA checkpoint. You can do that with tape on the ground. You can do that with cones. Lots of different ways to guide the individuals through the right place. And that walkway can be anywhere from 4 to 5 feet wide up to about 12 feet wide. Now, obviously, with social distancing guidelines in place, you don't want to have people crowded up next to each other as they walk through. So the more narrow a walkway you create, that will help smooth out the traffic flow and keep people properly distanced. But again, you want to guide the individuals next to that black body as they walk through. So here is an example of that in place, using the rope stanchions to guide the individuals back and forth. You see the thermal camera and the black body mounted to the wall up to the right there. And again, the individuals coming in would be guided back and forth a couple of times. Then they would proceed through the screening area and go on about their business. Here's another application of it. You see the black body on the left there. The camera up inside that red circle. It's a little hard to see. And the individuals, again, will just walk through this hallway. And if they don't show an elevated temperature, they don't set off the alarm, they can just keep on walking. Now, this product or this solution was brought to the US just a few months ago, specifically to deal with coronavirus, of course, but it's not a new technology. This is not something that we threw together in January or February to launch into the market because of coronavirus, like some of the other companies out there. This technology for Dahua was developed back around the time of the original SARS epidemic back in 03 or 04. And it's been in use consistently around the world since then. We just have not had a reason to bring it into the US market until now. So you can see two of these examples here, Shanghai Railway Station and Hangzhou Metro. These are two of the world's busiest metro stations. They screen all passengers as they enter, so literally hundreds and hundreds of people per hour. And so this system can scale up to very large as needed. Just a couple of other case studies. We have airports, we have office buildings, we have hospitals. Now, these case studies, again, are global because we've had relatively limited time with the product here in the US, but we do now have several US-based case studies in-house. We are not allowed to publicize them at this point, but we can provide information on these case studies individually if you reach out to us or your sales rep or the guys at cctv.net to Jack. I mean, we can get all of this information to you as needed. So real quick, here's a short little video of the system in action. Now in this video, you can see the black body up on the left-hand corner here. And you might be able to see, if you look closely, a green box drawn around the face of it. That is, like I said, during the setup process, part of the setup is to draw that box around the black body so the camera knows where it is and can see it at all times. And then the other part of the setup, one of the other parts, is to draw this blue box, which is the actual detection area, which is the only place in the scene where it's looking for facial detection and temperature detection. So I'll play this video real quick and you'll see the individuals walk through. And again, as I mentioned, if the people are wearing glasses or you'll see somebody come through with a mask on in a minute, those things are typically not going to interfere with our ability to read temperatures. Now, one thing that's very important, especially if you're using the tripods for the setup process, if that black body moves or is bumped or knocked over after setup is done, you will get, like I said a minute ago, a black body error and the camera will stop reading accurately. But really all it takes is to set the black body back up again and get it moved into place behind that green box. If you can't for some reason do that, or if you completely move the solution to another location, you'll have to go back through the setup process all over again. And that includes some calibration steps and things like that. But if somebody just happens to bump into or move that black body, the tripod it's on, it is possible just to replace it and get it lined back up with the box that was done during the setup process. So you can actually recover the system fairly quickly if that happens. So a couple of questions that come up frequently, and one of them I already mentioned. Can I get the alerts on a phone? Yes, absolutely. Our free DMSS app for iPhone and Android can connect to either the NVR or the camera itself and provide push notifications on a high temperature alert. Now, in order to get, so you see the alert here. It shows you a close-up snapshot. It shows you the temperature that set off the warning, and it shows you a wider, the full view of the camera at the time of that incident. Now you'll also see it has two links to either playback or live. Now, in order for those links to work, you do have to have the NVR in place. If you want to go back and see the playback from the incident or switch to the camera live, you will need to have the NVR for that, but not just to get the alert. You can do that directly from the camera. You just get more information and more features if you have the NVR in place. Our software client applications for Mac and PC, both our Smart PSS and our DSS Express S free software packages, they currently do not process the temperature alerts. So you can see the temperature, the video streams through that. You can see the temperature data overlay over the person's face, but you cannot get any kind of alert based on a high temperature. So for a secondary viewing station, those might be okay. But again, in order to get the actual alerts and for actions to happen, you need the NVR in place. Now, during the setup process, a laptop or a PC is necessary. There are some things you need to do directly on the NVR and the camera that you need a laptop for. But once the system is set up and running, you do not need any kind of an external PC of any kind. As long as you have the three main components of the camera, the black body, and the NVR, you have a complete self-contained closed system. You do not need anything else to work it. Likewise, you do not need any kind of external network connection or internet connection. Unless you want to do notifications and emails or secondary viewing locations, things like that, then obviously you would need an external network connection to do that. However, just for the system to operate, you do not need any kind of an external network connection. It doesn't have to connect to any other type of network. It's designed to be completely closed and self-contained. So we have lots of backup documentation available. We have data sheets, white papers, brochures, all kinds of things on our website. We have some of the government documents like the CDC and FDA guidelines on the use of this technology. We have those available. So we have lots of backing documentation for you if needed. So before we continue on to the next solution, I want to open it back up, see if there's any more questions on this one.
None from me. If everyone else is cool, I think we can go forward.
All right, we'll move forward then. So the next solution, as I mentioned back in the beginning, is a little bit different. This one is designed to screen individuals one-on-one. So instead of it looking at a whole group of people and reading them at the same time, with this solution, you need to, or the person would need to walk in front of it, directly up to it, present their face. It will do two things. It'll read their temperature, and it can determine whether or not they're wearing a mask. Now, as a third function, this unit can also do facial recognition. And we'll touch on that in just a minute. But the basic two functions of this device are temperature reading and mask detection. And at that point, it's designed to be a standalone device. So the individual would walk up and read, and it would read their face, and then it would give them a green or red indicator saying go or no go. Now, even though this is a one person at a time solution, it is a very rapid system as well. It takes a half second or less to read a person's temperature and determine whether or not they're reading a mask. So it's a very, very quick system. Now, a couple of notes about this solution. The accuracy is a little bit lower on this one. It's 0.9 degrees Fahrenheit instead of 0.5 degrees. So a couple of tenths of a degree lower in accuracy, mostly because this system is not using the black body as a reference. Because each person gets directly in front of the camera, you wouldn't be able to use that black body in the background. And also, this system is to be installed indoors. Its operating range, you can see there, is about 60 degrees to 90 degrees. So again, this system is designed to be used indoors in a controlled environment. But again, very, very rapid screening. Now, we have a couple of different mounting options. Out of the box, the device is designed to be mounted to a wall. It comes with a wall mount plate that you can pop the device on after you secure it. But then we also have both desktop and floor mount options available for mounting. And like I mentioned, so the idea is that the individual would walk up in front of this device. It begins doing a screening at about 6 feet away as you approach. And so the detection area is from between about 1 feet away to about 6 feet away. And when you approach, it checks if you have an elevated temperature and whether or not you're wearing a mask. It has audible announcements that can play, high temperature detected, or please put on your mask. Now, this device also has a alarm output built into it, so you could tie that in, again, to an access control system if you wanted to trigger a door to lock if someone is not wearing a mask or if they have a high temperature. And this device also does have a Wiegand access control output. At the current time, it's only designed to work with our own Dahua's own access control system. We are working on changing that, hopefully. But for the current time, you can use it with a Dahua access control system in place. And at that point, you could actually use it as a facial recognition access control reader. That's actually what this device was originally designed for. And then we added the thermal camera to it. So you could, if you had a Dahua access control system in place, you could have a person read their face, temperature reading, mask reading, facial recognition, and then let them in or not based on a combination of any of those three conditions. Again, with a Dahua access control system. So a couple of other features, we've already talked about these. It does have a touchscreen that is mostly for setup. The users, the people coming in do not have to touch the device at all. They just walk in front of it and present their face. It all happens automatically. So this device, again, some questions that come in. This device needs to have about 20-minute warm-up time every time it's turned on. And you do the calibration steps the first time the system is set up, and then you will need to repeat that calibration or verify the calibration at least once a year. You shouldn't need to do it more often than that, again, unless the system is moved to another location. If the system stays in place and is set up and calibrated properly in the beginning, you shouldn't need to recalibrate it more than once a year. So as I mentioned, the read rate is about a half second or less. And I mentioned the Wiegand access control. But again, right now, currently, that's only with Dahua's own access control system. So the ambient temperature range, as I mentioned, between 60 and 90 degrees. This says that we're not supporting any third-party integration. That being said, our API is available. If you want to contact Jack, who can reach out to me for that. If you wanted to try and develop your own integration with another system, we can send you our SDK so you can develop that on your own. We're just not doing that from Dahua's standpoint at this point. Can it measure the temperature of people walking by? No, each person has to stand in front of it facing the terminal. And again, something to go back really quick to the first solution, the people need to be walking in that solution directly towards the camera. Again, they cannot walk across the front of the camera. Now, even if they're walking, or as long as they're walking directly towards the camera, even if they turn their head, we can still get a reading from the side of the face, but we need them to be walking towards the camera to do that. With this solution, the person needs to stand directly in front of the terminal, facing the terminal. So here again is a quick little video showing the system in action. The first little scene you'll see is the system being able to read from about 6 feet away. And then the second one is will show you how quick the system can read. So I'll go ahead and play those. So now you can see here as they walk through, they're being screened very quickly, but they are presenting their face in front of the terminal. So it does work quickly, but again, that's dependent on the individuals presenting their face properly and being in the detection area to do it. So that's pretty much what I have on the two Dahua technologies. Are there any questions on that technology? You know what? Let me bring one more thing up about this that I didn't mention. To go back to the first question about alerts and NVRs and such. So as I mentioned, this device is designed to be standalone. This also can connect directly to the phone app, the DMSS phone app. The device itself has both Wi-Fi connectivity and wired Ethernet, so you can connect it either way. And by itself, like I said, you can connect it directly to the DMSS app for push notification alerts. If you wanted to, however, if you want to store the capture images, the video of people being screened, the snapshots, things like that, you need the NVR in place. Also, and it's the same NVR, the NVR 5216, which is the only model that works with these thermal solutions. Same one as the big system. If you want to, so if you want to save the video shots, the snapshots, or if you want to do email alerting, text message alerting, then you will again need the NVR in place. If you just want to connect this device to the network and then directly to the phone app, you can absolutely do that too without the NVR. But if you want more elaborate storage, recording, or alerting functions, you will need the NVR. So that is what I have. So again, if there are any questions on this solution.
None from me. You covered all the bases pretty well. If we don't have anything from any of our other participants.
Okay, then that's what we have. So Jack, I'll hand it back to you.
Great, awesome. Thank you so much, Stephen. CCTV.net really appreciates you and the rest of the people at Dahua for making this happen. And I just wanted to thank you personally for your flexibility with this webinar and the issues we had last week. I really appreciate that.
Yeah, no problem at all.
All right, well, thank you so much, Stephen.
All right, Jack.
Good morning.
Yep, anytime. Bye-bye.
Bye. All right, and thank you to everybody else who joined. And that's it. Good morning, everybody. Good night.